Fantastic. I'm going to go ahead and get started here. My name is Chad Truppel. I am the PVC National Sales Manager for Carlisle Construction Materials. I'm employed by CCM corporately. However, I support our local independent representatives in the state of Florida, Compass Sales Group. So excited to be here today. But before I jump in, I want to simply verify, or excuse me, thank the AIA Florida team for putting on such a phenomenal event. When I learned of the number of folks attending, I was pleasantly surprised. So well done. Hats off to you, and appreciate the opportunity to be in front of you today. Today I'm going to cover PVC roofing materials. Really timely in terms of covering this particular low slope roofing option, simply because PVC is seeing tremendous growth, and it is now the second largest single ply membrane across the country when you think about EPM, TPO, and PVC. So look forward to diving in here, and we'll do that right now. Before I dive in, just want to advise that this is the one and only opportunity that we get to kind of promote our company. So this, Carlisle Construction Materials is a building envelopes manufacturer, and so we're very well known on the rooftop. We're basic in all single ply membrane manufacturing, EPDM, TPO, and PVC, and all the corresponding accessories within those assemblies. But also are basic in continuous wall insulation, below grade blindside waterproofing, exterior metal cladding, metal edge, and as well as metal roofing. And so we really view ourselves as a six-sided building envelopes manufacturer. And if you're interested in learning more about how we can provide some services to you all, the specifier specific to building envelope solutions, we'd love to have that conversation with you. Recognize that those tie-ins from roof to wall, wall to below grade can be complicated, but we can simplify that for you with our systems and services and solutions that we provide in that space. So I represent Carlisle Construction Materials, and specifically in our commercial roofing division. So this is an AIA accredited program. As the AIA folks suggested, they'll work on getting the credits to you following the program. And before I dive in, of course, if there's any questions, I'll happily take them. Please post them in the Q&A section or within the chat. I'll try to monitor that throughout. However, I am running solo today, so that could be a little challenging from a technical standpoint. But at the very least, I'll take a look at all of those submissions and get a response back to you. And I think it sounded like AIA will post those responses on the website. So with that, we'll go ahead and jump in. So just want to briefly touch on the learning objectives, and I'm going to go ahead and stop my video here so we can limit some distractions. But learning objectives for today's PVC roofing course is really, let's start with the basics, understand PVC chemistry, its environmental safety characteristics, and of course, the features and benefits of PVC. From there, we will understand the components of PVC membranes, such as membrane construction, types of scrim, and then formulation in terms of how that can impact not only longevity and durability, but also performance. From there, there's been obviously a lot of innovation and advancement in PVC, and we'll talk about what some of those advancements look like and how that's changed over time. And then lastly, kind of do a deep dive into the specific roofing standards that are associated with PVC, and it is very, very different than that of other low slope commercial roofing applications in that there's multiple ASTMs, and so can oftentimes be a little bit confusing unless you're educated, and that's really what we're trying to accomplish today. So with that, we'll start with just the basic PVC chemistry and makeup. So PVC stands for polyvinyl chloride, of course, and the makeup is rather basic. It's basically just two main components that make up PVC, and that's natural gas and salt water. And that's a really good thing when you think about sustainability, and we'll talk about that as we kind of work through the presentation today. But really how PVC is made, whether it's rigid or flexible, is quite simple. I say that kind of tongue in cheek, but this infographic kind of oversimplifies it. But if you take natural gas, you crack it, you get ethylene. Salt water, you run through an electrolysis process, and then of course chloride is extracted. And at that point, you have vinyl chloride monomer, or the gas. You expose it to UV light and you get PVC resin. And at this point is where you kind of have the fork in the road from a manufacturing standpoint. Do you want to make rigid PVC that you typically see in piping and things like that, or do you want to make flexible PVC that's often used for weatherproofing membranes like PVC single ply? So from there, we want to shift gears just a little bit and talk about the benefits of PVC and why choose PVC for your next roofing application. So one, and probably the thing that resonates the most with the design community, consultants, is that PVC's got a proven track record. Reinforced PVC has been used in roofing for over 50 years, and even more so when you expand outside of the domestic United States and look internationally. But domestically, it's performed very well for over 50 years, and that gives folks a lot of confidence in long-term durability and its resiliency as it relates to kind of harsh environments, specifically like you would see in the state of Florida with intense UV exposure. From there, probably the most well-known benefit of PVC is its chemical resistance, or at least highly touted benefit is chemical resistance. And so this is important when you think about application and or product placement. So this is choosing the right membrane type for the application. So if you're specifying restaurants or food processing facilities, or it's in the industrial manufacturing space and or airports, PVC is really a membrane type that you're going to want to look at pretty heavily and likely use in those applications, because when those chemicals come in contact with the PVC membrane, it's inherently more chemically resistant than that of TPO or EPDM, and a lot of that is due to the chlorine in the sheet. And so that's a big benefit that PVC is able to tout, and it's one that these types of buildings and or chemicals that could interact with the membrane type really are tailor-made for the PVC as it relates to consideration for that assembly. The PVC product segment's got a really good sustainability story, not only from how it's made, but then if you think about kind of end of life, what do you do with it? But we'll start on the front side. Because of its basic makeup of natural gas and salt, it is the only thermoplastic that's out there that's not produced or manufactured from 100% fossil fuels. And so that's a good thing, obviously, and it helps us limit kind of that embodied carbon footprint that it requires to produce and manufacture PVC that's significantly less than that of other single ply membrane options and or other low slope commercial applications for that matter. And so it's got a good sustainability on the very front end of the sales cycle or life cycle. And then if you think kind of the opposite end of that spectrum, its recyclability is rather impressive. And so, in this particular image, you're seeing vinyl window sashes and jambs and such, and basically, you can recycle PVC 7 times without losing its physical property characteristics, which is impressive. And so, whether it's post-industrial or post-consumer, PVC's got a really good story as it relates to kind of recyclability and kind of the circularity of that particular thermoplastic, and no other thermoplastics can tout similar sustainability characteristics. So that's a big thing. Obviously, in the state of Florida, there's far more cooling degree days than there are heating degree days. So a reflective roof makes sense. But it's not just the membrane alone, right? It requires for the most energy efficient buildings, it does require a sufficient insulation package to make sure that you're extracting the most energy savings that you possibly can from that roofing assembly. But the reflectivity values that PVC allow obviously help contribute to those energy savings, and certainly help you, the specifier, articulate that value prop to the building owner when specifying white membranes. Another benefit, of course, that is definitely well known, and of course one that the design community heavily leans into, is its seam integrity. So not unlike other thermoplastics, it's a heat weldable system, and so you apply hot heat or hot air, and then pressure, and it makes the two sheets basically essentially monolithic. With PVC, the finished seam is actually a little bit different than other thermoplastics, as you can see kind of in that bottom right-hand corner image, in that it's got this intentional bleed out. So that black kind of bleed out that you see is the bottom ply as it's melted onto the other sheet and kind of fusing together to make a monolithic seam. It's a visual indicator that you have a good weld. So it tells you or the installer that, you know, that heat welder was set at the right speed and the right temperature and applied the appropriate amount of pressure to make a good seam. That gives you a good visual indicator, is that intentional bleed out. You don't get that from other thermoplastics. So kind of this inherent benefit that you get just by using PVC versus other thermoplastics. That doesn't mean that you don't do test probes or test, you know, you don't, it means that you still have to probe this roof to ensure you don't have any cold welds or voids. And so, but this is a good indicator from a visual standpoint. Another characteristic of PVC that, in my opinion, isn't touted enough is its fire resistance. It's the most fire resistant single ply membrane out there, and of course, it's by far and away better than that of asphaltic roofing products as well. And you think about where you would benefit from this. This image does a really good job of depicting that, and that's solar-ready roofs, for example, or roofs that will also, you know, that have solar on it. Unfortunately, these panels do catch on fire, whether it's the wiring harnesses, the panels themselves. Sometimes they catch on fire. The benefits of PVC is if you remove the fire source, if you extinguish, you know, that fire on that panel, the PVC membrane itself is actually self-extinguishing, and again, a lot of that has to do with its basic chemistry and the chlorine component of the chemistry or the makeup, if you will. And so that's a great benefit, especially in the state of Florida, if you're thinking about solar panels as you're designing that roof as well. Additionally, we're seeing a lot of designers in the data center space really specify PVC, and they're telling us one of those main reasons, of course, is its fire characteristics as well versus some of the other single ply membranes. So that's the high level kind of features and benefits of PVC, and now we'll take a deep dive into the membrane construction of PVC membranes. So in the PVC space, this image does a really good job of kind of showing what's common in the PVC segment of the business. And that's, you know, we'll work from top left and around, but first starting with the most common, which is the polyester reinforced PVC. This makes up a significant portion of the overall market, the majority of. But you also see fiberglass reinforced. So this is where PVC is very different than that of TPO or EPDM, in that there's several different types of reinforcements. So you got to be aware of that. And there's certain ways to write these types of scrim in your specification. And we can certainly help with that. From there, on the bottom, you'll see we have KEE, or ketone ethylene ester. This is basically an enhancement to the formulation that has inherent benefits that I'll speak of here in a few slides. But there's key options, there's key HP options, and then of course there's that bareback that's commonly known, and you can apply an external reinforcement or a fleece to the bottom ply, and that gives you some really unique options for recovery options, where you can go over top of the existing roof, provided there's only one. Provides better uplift ratings and some better puncture warranty options as well. And so the theme that I'm really trying to hit home on here with regards to PVC is that you got to do your homework. PVC is very, very different than thermoplastics. I mentioned early on in kind of the intro that there's two different standards. We'll speak about those here in a second, but beyond that, there's different scrim types. There's PVC, there's key, and then we'll even kind of complicate it a little bit more in that not all PVC is created equal, or stated differently, it's typically not apples to apples in the PVC space. There's many folks that either market or ultimately produce PVC, and they're all slightly different. So it's really important to scrutinize the manufacturer in which you're looking to write in your specification to ensure it's going to achieve what you're ultimately looking for. And so kind of to expand on that thought a little bit more, what you're looking at now is kind of a cross section of a standard 60 mil nominal PVC polyester reinforced membrane. And as you can kind of look at this, there's two distinct layers. There's a top layer and there's a bottom layer. The top layer is really where you're going to get all the weathering performance in a PVC membrane sheet. And then the bottom layer has some of that weathering package, but far less of it, right? It still is PVC by nature, as measured by the ASTM, but it doesn't have a lot of the weathering package, and it's just loaded with, PVC resin, plasticizers, antimicrobial package, and things like that. And so, but notice it's a 50-50 split. That is not common. It's not the majority of the PVC membranes in the marketplace, but there's a benefit to this, and you'll see that as we kind of walk through the subsequent slides. And of course, the reinforcement fabric is right in the middle. If you take a look at another PVC sheet that's out in the marketplace, it's pretty different, right? Where it took that 50-50 ratio, now it's kind of 1/3 to 2/3. And really, the only benefit to this is a lower cost of production, right? These two sheets, this sheet, the sheet I just showed previously, are at the same market price, but performance, long-term performance, is absolutely sacrificed with this type of manufacturing. Take a little bit more different view with yet another PVC membrane that's out in the marketplace. Notice this now takes that top ply and it not only pushes it more towards the top of that sheet, so thickness over scrim, but also takes that top ply and kind of divides it into two. And so as you kind of work from top to bottom, it's got less and less and less of that weathering package. And again, the main benefit of this is cost reduction from a production standpoint, a manufacturing standpoint, and really what's sacrificed in the market is long-term performance. So message here is scrutinize PVC membranes that you're being asked to insert into your spec, and those that you're not familiar with, again, just do your homework. PVC is again a much different animal. Lean into your independent rep team in the state of Florida, Compass Sales, but you can also reach out to me directly, and we can certainly help you out in terms of better understanding the different manufacturers and how they go to market with the types of sheets that they produce. So from there, we'll talk about the different types of reinforcement. Again, there's polyester reinforcement and there is fiberglass reinforcement. So we'll talk about two of those. This is the most common reinforcement used in PVC roofing, and it's the weft knit polyester tie yarn. You'll note that the reinforcement yarns are not all knitted together, but they lay on top of each other, and that's really intentional. The yarns are really the top yarn and the bottom yarn. They're really tied together or bound together by this, what we call a tie yarn or weft inserted. So when this material is actually punctured and or it starts to tear, what will happen is that tie yarn will break, and it'll allow those larger strands to kind of bunch up together, and that bunching will limit the expansion or the continuation of that tear or puncture further into the field of the roof. And so really popular polyester reinforcement fabric and the most common in the space. And again, this particular reinforcement makes up the majority of the PVC market. That said, there's also fiberglass reinforcement, and there's several different types. As you can see on this slide, there's the lino weave and there's the glass mat. If you think about the lino weave, there's a lot of thread. There's a higher thread count here, which minimizes the voids in between the perpendicular and the vertical and the horizontal threads themselves, or reinforcement fabric. And really, that void is what allows you to melt that top ply and the bottom ply. And so this has some performance flaws, if you will, because of its how it's actually bound together with the top ply and the bottom ply. On the glass mat version, you can see there's no voids where you can melt the top ply and bottom ply together to make that one single ply. And so there's oftentimes adhesive used to make sure that this fabric stays laminated in the production line for that top line and that bottom, or that top ply and that bottom ply. Because of these limitations, you can only use this type of reinforcement fabric for fully adhered systems only, and you cannot use it for mechanically attached assemblies and or Ronabond assemblies. And so That's all due to the fact it's got low tear, puncture, and breaking strengths. And we'll talk about that here in the next couple of slides in terms of what that looks like from a data perspective. So naturally, I think we know the answer to this. It's kind of rhetorical based on what I just covered, but which scrim is better, polyester or fiberglass? And so we'll do a deeper dive into that. On this screen does a really good job of kind of just oversimplifying this in terms of what is better, and really it's stark in terms of the differences and the benefits that you get from polyester scrim versus a fiberglass scrim. As mentioned, tearing, breaking, and puncture strength is increased dramatically. I mean, you're talking 381%, 128, 9%, and 100% respectively. And the only benefit for fiberglass is the linear dimensional stability, which is 1/3 of 1%. So it's really nominal, and that's almost negated entirely as soon as you fully adhere that membrane to the substrate. So it's pretty clear which reinforcement is better from a performance standpoint. Again, you also got to keep in mind the limitations that you have from a install standpoint, meaning fully adhered and/or mechanical attachment. So that said, there's more than one type of polyester scrim, and we'll talk about that here momentarily in terms of how to differentiate higher performing scrims inside of your specification. We talked about fleeceback. Fleeceback's a great product, especially in the state of Florida. Gives you a lot of unique opportunities from a recovery standpoint. It's got really, really strong uplift rating, significantly better than that of bareback and fully adhered options. It gives you some added puncture warranty options, hail as well, in terms of what's available when fleeceback is leveraged or used in the assembly. It is an exterior reinforcement in addition to the internal reinforcement that we talked about. Again, talked about superior uplift ratings. I mean, we're talking FM 1-990. That's just incredible. You can, with today's technology in terms of adhesives, we can use low-rise foam as pictured there for the membrane attachment, and of course use that for the insulation attachment. So kind of a one adhesive to kind of solve both those attachment challenges or just scenarios. And when you do both the top membrane attachment with low-rise foam and ISO attachment with low-rise foam, you of course can add some additional R value to the overall assembly. So that's an inherent benefit to extract. And installation is very quiet. It's non-penetrating, very low odor. So occupied spaces, fleeceback makes a lot of sense. Now we're going to talk about the differences between PVC, KEE, and or KEEHP. So it's kind of understanding how these differ from one another. But first, we'll start with what is KEE. As mentioned previously, KEE is ketone ethylene ester, and it was developed by DuPont in the 70s. And it's an addition to the liquid plasticizers in the membrane composition. And plasticizers are what gives PVC its flexibility, right? So absent of a plasticizer, you have rigid PVC piping, for example. What key is so it's liquid plastic. It doesn't replace liquid plasticizers. It's in addition to. But because key is a solid versus a liquid, it's got a higher molecular weight, and so it stays in the sheet longer. So when PVC fails in 30 years, say, what happens is the plasticizers, what makes that sheet flexible, migrate out of that sheet, and then it becomes brittle. The solid plasticizer, or the key that's in the sheet, stays in the sheet longer because of its higher molecular weight, and so it gives you enhanced long-term performance characteristics. And so, to put that more simply, standard 60 mil PVC from most manufacturers, you can get a 20-year warranty. With 60 mil key, same thickness, same gauge, you can get an extra 5 years from the manufacturer from a warranty coverage standpoint. So you take it from 20 to 25. And again, it's all due to the fact that it's a higher molecular weight. It's a solid plasticizer, stays in the sheet longer. The benefits of key are much like the benefits that you saw on the previous slides with regards to PVC. It's got its chemical resistance, its UV protection, and its flexibility. They're all enhanced, however, with KE. I often say key is PVC on steroids, to think of it in a simpler way. And again, because PVC just needs to be finicky and difficult compared to the rest of the single ply membranes, there's not just one version of key. There's key and there's key HP. And that HP stands for high performance. And it has even a higher molecular weight. And so by default, it'll stay in the sheet longer, and again, enhance that long-term performance even more. Additionally, when you go from key to key HP, for example, they're just different grades of key. There's other benefits outside of long-term performance and its weldability. With key, the more you put into a sheet, the harder it becomes to weld. With key HP, because it's a higher grade, you can put less of it in the sheet and still extract the same benefits, if not more, than traditional key with higher rates of concentration in that formulation. This is a difficult slide to read, I understand, but really it's an independent welding study that DuPont conducted, and really you can see on the far left, obviously red's bad, green's good. Red is essentially cold welds at certain speeds and temperatures, and this is with higher rates of key on the top and lower rates of key on the bottom of that left-hand column, and then the other side is key HP. And so really kind of to summarize that, the less key you use, the easier it is to weld. But you don't want to use less key unless you're using higher performing key or higher grade of key. Additional benefits for key, while I recognize maybe not so relevant in the state of Florida, but it's better cold weather flexibility. Again, it's significantly better with HP versus key. And then this is taking a look at key HP and key kind of under magnification, in this case 20 times. And it's simulating 20 years in the South Florida sun. And so you can see key starts to show, standard key starts to show some surface crazing and cracking, which is early signs of premature failure or failure in that sheet. And then the HP, of course, not only surpassed the key where it started to show the crazing and cracking, but kind of went beyond that as well. And so again, that kind of puts some data behind this enhanced performance that you get with heat aging. Again, talked about chemical resistance. These are percentage increases above that of standard PVC when the membrane comes in contact with these types of chemicals. And then kind of just an inherent benefit of key HP is kind of the aesthetics. And because it's going to stay in the sheet longer, it'll help that PVC sheet stay white longer. And it's better, of course, PVC and key, and then of course key HP is the best performing in that space. Last couple, so shift gears to types and standards. As mentioned, there's two different standards within the PVC segment. It's the D4434 standard, and that's the standard PVC ASTM standard. And then there's the D6754, and this is a key standard. In order to meet either one of these standards, you have to meet both formulation and the physical property characteristics. You can't meet one and not the other and claim that you satisfy the standard. So the main difference between the 4434 and the 6754 is the formulation. And so in the 4434, the polymer content has to be greater than 50%. And that's really kind of how you differentiate PVC from that of, like, for example, TPO. And then you can see the physical characteristics: min thickness, 36 mils, and min thickness over scrim. On the 6754, the main difference is the polymer is greater than 50% key. And so that's really its differentiator from that of the 4434. And of course, there's some pretty significantly different physical characteristics, mainly thickness over scrim, that you need to be mindful of. Fun fact, the 4434 standard was one of the first single ply standards in all of low slope single ply commercial roofing. So that's cool. And then 6754, excuse me, is one of the newest. And the main reason there's a key standard, of course, there's some manufacturers out there that could meet the 4434, so they lobbied to have a standard of their own created, but just be mindful when specifying that standard that it could be a proprietary spec. Within the 4434, you have the ability to specify the type of scrim, and this is polyester scrim. And so we talked about the benefits of polyester scrim versus that of fiberglass scrim. Within the polyester family, there's even different types, and you guessed it, one can be better than the other. Type 2 is that fiberglass reinforcement. Type 3 is a polyester, and type 4 is also a polyester. But there's significant benefits when you go type 4 versus type 3. And again, it's all related to breaking, elongation, and tearing strength. And so you can write this into your specifications when you're writing the standard that you'd like the membrane sheet to meet. And then you can specify the type of internal scrim reinforcement you're after. Highly recommend, of course, type 4 because of the added performance characteristics it brings. Shift gears just a little bit to give you a glimpse in terms of what the overall PVC roofing market looks like. Be mindful, this isn't just related to the state of Florida. This is a national lens that we're looking through, but pretty comparable in the state of Florida as well. And as I mentioned, PVC, standard PVC with polyester reinforcement is the majority of the market. It's about 56% of the overall market. If we kind of work from right to left, the next is the FRS PVC market. So this is that fiberglass reinforcement. It only makes up about 6% of the market. And I think hopefully through the learnings of today, you can understand why that would be. And mainly it's because of the limitations it has from an installation standpoint. Fleeceback PVC is growing. It's about 11% of the overall market. The difference, I think, that you would see from a national view versus a Florida view is that PVC share would be larger. So that's a growing segment within the PVC product category because of the features and benefits we spoke about a couple slides ago. The greater than 50% key, so that's the 6754 standard, is only about 3% of the overall market. And you likely picked up on why that could be, because it's essentially a singular manufacturer that plays in that space. Less than 50% key content, or every other membrane that claims that they have key but not meeting the 6754 makes up about 15% of the market. And then PVC color, so think of patina grains, your Mansard browns, things like that, make up about 5% of the market. And I'll show you here in a couple slides where you typically see some of the PVC colors when it's not like a small logo, for example, on the roof. And then a PVC metal profile, which is kind of leading to that PVC colors and where you'll see it. So I'll show you that here in a sec. So this is a PVC assembly that really kind of replicates the look of a standing seam metal roof. And then how we accomplish that, of course, is in the field of the roof. Obviously, that's PVC membrane adhered to a substrate, and then we come back and install these metal roof profiles that essentially just get welded to the roof membrane sheathing by way of these flanges, and then it's got that vertical rib. And you have the ability to put these on center at whatever you'd like. Contractors are doing some unique things where they're kind of making a template out, a pan template, and using that as a kind of a spacer in between each of these ribs. But a pretty cool assembly. You can get the performance of a single ply roof, the cost, and the look of a metal roof that are a little bit more economical, if that's something that you're interested in. PVC is at times can pose some unique challenges, specifically when there's difficult penetrations to flash. So think like any of the ones that you're seeing on the screen, whether that's uh, uh, catwalks or I-beams or any other funky penetrations that come through that roof. There's some liquid flashings that are really slick and perform really, really well with these hard to flash penetrations. It's also really good for tie-ins. PVC is not really compatible with a lot of other things, and so making those tie-ins to dissimilar materials can be challenging. But liquid flashing is a solution for that rooftop challenge. Coated metal. This was really the common detail that you would often see, specifically if there was like a drip edge detail with PVC, where you needed to have the ability to weld the metal to the membrane field sheet, because for a long time there wasn't pressure sensitive options until now. So you have a coated option as shown there, but also there's innovation in this space and innovation that's growing in this space, where there's a pressure sensitive cover strip that can now be used for a drip edge application. Traditionally, again, this needed to be coated metal because there wasn't pressure sensitive technology out there for PVC. Because if you're familiar with PVC forever, the old saying was nothing sticks to PVC, and that's pretty accurate except for this. So this really gives you a lot of flexibility as the specifier, the building owner, to really pick your color of choice from a Kynar metal standpoint on that edge. Whereas with coated metal, you're limited to just standard, white, tans, and grays. So gives a lot of flexibility for color options. Contractors can then bend their own metal, encourage that they are an ES1 certified fabricator in order to meet building code. But it gives a lot of flexibility and options, not only from the specifier building owner side, from a color options, but also gives the contractor the ability to bend this metal themselves in their shops as opposed to prefabricated metal. Pressurized adhesives have made their way into the market, we'll say, over the last 5 to 8 years. It is our opinion that in time, pressurized adhesives will likely displace that of traditional roller applied adhesives for a lot of different reasons. In the PVC space, specifically what you're seeing here, not only is it cheaper from a material standpoint than traditional bonding adhesive, but also its speed of application is significantly improved. So you can do far more with less. You can get off that roof quicker, get on to the next, limits kind of flash off time, waiting time for the contractors. It's just a really great advancement in technology from an adhesive standpoint. Additionally, other innovation coming into the marketplace is temporary roof protective coverings. And so really think about this as a film that's on the top ply of that membrane that stays on the top of that sheet throughout the installation. And the benefit here is, think about if this is a recover over an old built up roof, or it was a coal tar pitch tear off and you're going back with a new white roof. I'm sure many of those on this call have seen what that roof looks like at the end of the installation, and it's not white. So this protective covering stays on that membrane and throughout the installation to keep it clean. So that way there's a white roof at the end of that install. It's got other benefits, like it helps you identify if there's maybe a tool that was dropped that maybe could have punctured the membrane. As you're kind of peeling that protective film off, it would kind of split around that puncture, and it'd give you a visual indicator that, hey, you might want to investigate that to ensure that there's not a breach in that membrane. So really slick product. There's creative ways to write this into your specification from a reflectivity value standpoint. But if you're interested in what that looks like, please reach out to your independent rep team or myself following the events of today and tomorrow. Of course, in the PVC space, there's also induction welded systems, very popular for wide open roofs, pretty quick install, not unlike what you'd see with other thermoplastic membranes. This kind of gives you an idea of what that looks like when you put it on an uplift table. The far left, that looks like a mattress. That's an induction welded system. The one on the right is a traditional mechanically attached system. There's some different performance ratings that you can get with one versus the other, but one very kind of layman terms benefit you would get, and most folks would quickly realize that is kind of limited sheet flutter. Sheet flutter on mechanically attached systems, as you kind of see on the right there, is intentional, but it can cause some acoustic challenges in that inside of that building, whereas induction welded systems, that wouldn't be the case. Again, in the PVC space, innovation continues. I encourage you, however, to look at who's innovating in this marketplace. It's not many. It's dominated by one manufacturer, but this is a really cool technology that was introduced back in around 2018, and it's a hook and loop system. The manufacturer partnered with Velcro, the brand, came out with this technology, and really what this allows you to do is eliminate almost all of the adhesives on that rooftop. So tailor-made for applications where you can't puncture the existing roof deck or assembly that you're going over. You don't want any odors, you don't want any smells. There's no temperature restrictions because you're ultimately eliminating almost all of the adhesives. So, that's obviously more prevalent north of you all. But really, and then as another benefit, helps with speed of application. There's a really cool case study out there I encourage you to take a look at, where these systems were installed in the Midwest. And a few years back, they experienced a derecho event or a straight line event, similar to hurricane force winds, if you will, in the Midwest. And these systems were installed. They didn't have the edge metal on yet, and a bunch of roofs that were installed at the same time with edge metal, fully adhered, not the hook and loop system, were all in the parking lot. And this system stayed intact, undeterred, without even the edge metal. And as most of you guys know, the edge metal is the most critical detail for that first line of defense in a wind event. So really great story. Incredible performance with this system, all the benefits of traditional fleece back, but then some. So kind of recap, why choose PVC? One, it's one of the fastest growing segments in low slope commercial roofing. Why? Greater adoption for application where it makes sense, where people want to benefit from its inherent benefits like chemical resistance, the fire resistance, the reflectivity, the sustainability story, the decades and decades of proven track record and performance, well over 50 years at this point domestically, its seam integrity. So a lot of reasons. State of Florida is a very large PVC market and growing, and we see a bright future for PVC roofing now and well into the future. And with that, I want to thank everybody for their time this morning. Just a tremendous turnout on a Tuesday morning at 8 o'clock. I thought with me going first, that wasn't going to be the case, but thank you very much for your time today. Happy to take any questions. I think there's some in the chat. I'll take a look at them in the interest of time and reply back to the folks at AIA. But thank you for your time. And with that, Wendy, I'm going to stop sharing and I'll toss it back over to you.
Thank you, Chad. Yeah, actually, we do have a few minutes left. I think your presentation goes until 9. So if you want to take a look at the Q&A, there's questions in the Q&A, and I think there's also some in the chat.
Yeah, let me try to go through some of these questions. I think the question is can we use PVC roofing material for interior flooring? Not to my knowledge. I have not seen that application. However, there's some other, if you're speaking from a waterproofing standpoint, there's certainly some options that we could talk to our sister company about. But I'll follow up after this event and get you an answer there. Is the bottom layer the most important layer, and what's the minimum recommended thickness of the top layer? So the recommended, there is requirements for minimum thickness over scrim as defined in those ASTM standards. And I can follow up and get those to you. They are embedded in that presentation. If you guys want copies of the presentations, we can certainly get them for you there. But I'd say no, from a long-term performance standpoint, the most important layer is the top layer. That's where all of your weathering performance and package is at, where your antimicrobial package is at. And so that would be the most important layer when you think about membrane construction. Why would you ever spec fiberglass reinforcement? Great question. Simple answer I can give you is that the incumbent in this space, that was their flagship product. And that's what was first introduced and was heavily adopted. And then with innovation, obviously, here comes polyester, and then above and beyond that, type 2 and type 3. And so, excuse me, type 3 and type 4 polyester. So it's a manufacturer preference and also ultimately something that they introduced into the market long ago. When we're talking about the hook in the loop system, how's the hook membrane attached to the substrate? So the substrate actually has the hook laminated on it in line in the manufacturing process, as does the fleece. The fleece is laminated in line on the membrane. The substrate can be either adhered to the roof deck or the existing assembly we're going over, or it can be mechanically attached. And then you just simply mate the two together like you would any other Velcro. So hopefully that answers that question. Regarding the hook and loop system, is the hook layer only attached to at a strip along the edge of the system? No, it's in the entirety of the. So if the roof membrane's 10 by 100, it's on that full 10 by 100 sheet, short of the seam, so you can make that seam. And is that hook layer attached with adhesive? It is in line in the manufacturing. Sorry, in the production line. Does the Velcro have Florida product approval numbers? Yes. Please get with your local rep. They can get you Florida product approvals and uplift ratings, but yes. How's the first layer of the insulation attached with the hook and loop? Again, it can either be fully adhered to the substrate or it can be mechanically attached. Are custom colors available? I think that's just in general in the PVC segment. Yes, but not by all manufacturers. Why PVC in the state of Florida versus TPO? For a lot of the reasons I described. Mainly, let's think about fire, for example. If you're going to specify a roof that would ultimately get solar on it, I'd highly recommend PVC because of the inherent fire characteristics that are superior in PVC versus that of TPO. If you're specifying a industrial plant that likely could dispense chemicals on the rooftop, PVC. Absolutely over TPO. If you're talking about warehousing, maybe not. If it's a cost play. But I'd also ask you to look at life cycle cost and what you get on from a long-term performance with PVC versus that of TPO. And then lastly, on that question, why TPO versus PVC? With PVC, if it's specified key and you only want to go 60 mil because of budget, you can get a 25-year warranty there, whereas with TPO, you can only get 20. Could you discuss the cost comparison, key versus regular PVC? Depends in terms of how it goes through the channel, but you could see anywhere from a 20 to 30% increase. But again, remember life cycle cost when you think about that upcharge. Which type PVC has the most color options and is it recommended when building in Florida? I'd say this, the lighter color, the better in the state of Florida. With darker colors, it doesn't help with, it actually kind of works against accelerated weathering, meaning stated differently, you could have premature weathering with darker colors in the state of Florida. Price difference between TPO versus PVC, and again, it's probably about 25 to 30%. But again, think life cycle costs and benefits that would be extracted. Simulated standing seam fins is the solid PVC material, or is there It's all PVC. I think the question is the PVC rib PVC material throughout? And the answer is yes. Obviously, it's a little bit flexible, so it's got some plasticizer in it, but by and large, the chemistry is pretty much the same. Wendy, I got through the questions and answers in what I believe is the Q&A section. I see there's about 24 comments in the chat too.
Yes.
What
Yeah,
would
we
you
still
like?
have a few more minutes. I'm looking, it looks like most of the ones at the beginning were for staff, which we've handled, but I think around 8:45, they start asking some questions for you. Some of them may be overlap. So I don't know if you want to just kind of glance through those.
Yeah, let me take a look at them real quick.
Okay.
Max, so the question about the standing seam profile, what is the max slope? That'd be dictated based on the max slope for the membrane itself, and I'd have to follow up on max slope. But we do have high slope ratings, but I don't know the slope off the top of my head. Apologies. How's the hook ply typically adhered to the deck? I think I talked about that. It's attached to the ISO, and then the loop is the fleece on the membrane. Looks like someone was dealing with a repair situation, and the question is simply how many patches are acceptable before it needs replaced. Good question. I would need to defer to our technical team. But yeah, great question. And without seeing kind of what we're seeing up there, not sure I can answer that as you're hopeful for. Yes, does the manufacturer do site visits to make sure materials are installed properly? Absolutely. Whether that's our independent representation in market, whether that's our company employed inspectors. Yeah, we can do pre, we can do job startup, we can do during, we can do post, of course, as we always do for warranty issuance. No real differences between key and key HP in terms of warranty advantages. They're one and the same. So that extension is both for key and key HP. However, it could be different depending on the manufacturer. I think I got through all of those questions, Wendy, in both the chat and the Q&A. And I appreciate the kind comments around the presentation. Thank you.
All right. Very good. All right, Chad, I think that's